Hey everybody, Mr. Piercy here, and I'm going to give you a demonstration as to our first triangle congruent shortcut side, 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 why it works. So here I have a piece of paper that I've drawn three segments on, segment A, B, BC, and CA. So what I'm going to do is I'm going to construct a triangle called ABC. And what we want to see is, well, if these three sides are used all the time, does it create congruent triangles or not? So using the way that I'm going to normally try to do these is first I'm going to copy the biggest side. It's just usually how I do it. And I'm just drawing a segment here. I'm not measuring it at all. So appearance-wise, segment BC is the longest one. So I'm going to open up my compass to be the length of BC, and I'm going to copy that segment. So here is point B, here is point C. So now I have to copy the other two segments. So let's go ahead and copy this one here. I'm going to copy CA. So what I'm going to do is I'm going to place the point of my compass at C, and I'm going to draw an arc. Somewhere along this arc is where point, oops, my compass moved. Somewhere along this arc is, let me clean that up. My compass moved on me. But somewhere along the arc is where point A is going to have to be. We're just not 100% sure where yet. So now I'm going to take my compass at point B, and I'm going to copy segment BA. So from point B, I'm going to see where would it intersect the other arc. And at that point right there, where the two arcs intersect, that's where point A should be. So I can close up my triangle, and now I have triangle ABC. Well, does it work all the time? Well, let's try it again. So let's see, I'll try fitting it here, see if we have room. Now what I'm going to do in here, instead of copying the biggest segment, I'm going to copy the shortest segment. So appearance-wise, the shortest segment looks like it's BA, or AB. So I already have my compass set to that, so I'll just turn my paper sideways here. Okay, so I'll label that. This is point A, this is point B. So I'm going to copy segment BC now. So again, somewhere along this arc is where point C should lie. So now I'll copy segment AC, and I'll kind of see from point A where would it intersect the other arc, and we see right about there. So this point right here is where C should be. So close up the triangle. Now, the way that I'm going to verify that I did these constructions correctly, that they actually gave me congruent shapes, is I'm going to just copy one with a piece of patty paper, and I will translate it to the second triangle. So here's A, B, and C. So moving it here, all right, let me get it in the right orientation. So A, B, and C, and those triangles do certainly appear to be congruent to each other. So that is actually a conjecture. It does go without saying that if I create something where all of the sides are the same, or all of the corresponding sides are the same, then the corresponding figures should also be the same. So anytime I create something where all three sides are the same in a triangle, we can show that they're congruent. Because you can look, even though I'm not measuring it here, the corresponding angles, A, B, and C, they are clearly the same measurement. I don't need to measure them to show that the corresponding angles are the same. We can see that they're the same. I mean, you're more than welcome to measure the three angles and show that they're all going to be congruent to each other and that they will all add up to be a sum of 180 degrees. But this is why we can use this shortcut using just the three corresponding sides of a triangle to show why uh, triangles will be congruent to each other. So we don't have to necessarily prove everything is the same. But anyway, again, this is just kind of a demonstration why that congruent shortcut works. And thanks for watching.